In this next video segment, we're going to talk about some unusual math operators, things beyond the basic. So you probably remember some of these from math classes that you've taken in the past, but you might be a little bit fuzzy on them because you probably don't use them all the time. So you might remember from the order of operations, please excuse my dear Aunt Sally, that the E stands for exponents, and you can perform exponents in Python in a very similar way to what you would use in a standard math class. You're probably used to writing exponents using a superscript, like this example, where you put a little tiny 2 above the number to indicate that you want to square this value, multiply it by itself. Or you might be used to using the caret notation. 3 caret 2 means the same thing, means 3 raised to the second power. Python doesn't support either of these particular formats. Instead, if you want to raise a value to a power, you use the operator that is 2 asterisks right next to each other. So 3 asterisk asterisk 2 means 3 raised to the second power, or 3 squared. Exactly the same thing that we saw in our examples up here. So the way to write that in Python is 3 asterisk asterisk 2. And you can probably guess that 2 asterisk asterisk 4 means 2 raised to the 4th power. And you might remember that exponents are just a fancy way of saying that you want to repeatedly multiply something. So if we're taking 3 squared, that means multiplying 3 times 3. So multiplying 3 by itself twice. 2 to the 4th power means multiplying 2 by itself 4 times. So it's 2 times 2 times 2 times 2, which turns out to be 16. It looks kind of weird, but once you get used to it, it works exactly the same way that exponents from your past math classes work. Another fancy mathematical operation that's available in Python is integer division. Remember from our examples in the basic math segment that whenever we evaluate a mathematical expression involving division, even if the operands are whole numbers, it always gives us a decimal result. So if we say 5 divided by 2, it'll evaluate to 2.5, decimal result. And if we evaluate 4 divided by 2, it's going to evaluate to 2.0. So even though it's 2 whole numbers and we get a whole number answer, it'll always give us a decimal answer when we use the standard division operator. Usually that's great, and that's the kind of answer that we want, but sometimes it's inconvenient and you want the division operator to give you an integer answer, not a floating point answer. If that ever occurs, you can force Python to give you an integer answer instead of a decimal answer using the integer division operator. It is 2 division operators right next to each other. So for integer division 2, is going to evaluate to 2, not 2.0. And 5 integer division 2 also evaluates to 2. In cases where there's a decimal answer, Python does not round up, it truncates the answer, which means it just ignores the decimal part. We know that 5 divided by 2 is really 2.5. But because we're using this integer division operator, Python is going to ignore the decimal piece of the answer and only store the whole number portion. So it will store 2 as the solution, even though the division operator evaluates to 2.5. It does not round up the way you might be used to in your standard math classes. So those are 2 fancy math operators that are available in Python. Another fancy math operator is called the modulus operator, which is an operator that gives you the integer remainder of a division operation. Sometimes you don't want to know how many times x goes into y. Instead, you want to know what's the leftover part that doesn't evenly get divided. So you want to know the remainder from the division problem. And in computer science, we call this calculation a modulus operation, and we do it with the modulus operator. In Python, that's denoted by the percent sign, even though this has absolutely nothing to do with standard percentages that you might be used to from a statistics class. Let's look at an example. Suppose we have value 1 and it's 10 and value 2 and it's 5. If we say value 1 modulus value 2, think about that, I'm going to write it down because that helps me think about how to work it out. So I'm doing 10 modulus 5. And so I would think, what is 10 divided by 5? So 5 goes into 10 2 times, and then what's the remainder? 10 divided by 5 equals 2, remainder 0, because 5 evenly goes into 10. So the result of the modulus operator is the remainder, it's 0. So this first example is going to print out 0, and we can test that out in Python. Let's do that now. So if I say value 1, assign it the value 10, value 2, assign it the value 5, and then assign result operation value 1 modulus value 2, print result, we'll print 0 because that's the remainder. Think about what it would be if you did 14 modulus 10. Again, I think it's helpful to write it down. It helps me figure it out. So it's 14 divided by 10 is, oops, I erased part of my answer. 14 divided by 10 is 1, remainder 4. So the result of the modulus operator is going to be 4. Let's do one more example. What's 5 modulus 2? 5 divided by 2. 2 goes into 5 2 times, and then the remainder is 1. So if we say result equals 5 modulus 2 and print the result, it's going to print a 1. So far, we've been doing a lot of examples where our arithmetic expressions only included literal numeric values. That's definitely a way that we can write arithmetic expressions in Python and software in general. But we can also write expressions that use lots of variables. So for example, we might have a program where we store the sum of everybody's test score, and we store the number of students in our course, maybe it's 6. And then we calculate the average test score. That's the sum of all the test scores divided by the number of students. And then we want to print that out. So in this case, we're using the value of the variables, sum of test scores divided by number of students, not the literal values 506. And that allows our program to be more flexible so that we could potentially store maybe a list of test scores and add them up within our program, and then we could use those results that are stored in our variables as part of our arithmetic expression. By the way, what do you think would print out here? What do you think average test score is going to be? You guys can use your calculator if you want to. So if sum of test scores is 500 and number of students is 6. Oops, I spelled students wrong, but that's okay. And then I set the average test score to be the sum of test scores divided by number of students. Spelled wrong. I print the result. It's going to print 83.333333. And again, if you had to use your calculator to calculate that, that's totally fine.